Hey guys, welcome back. In this video, we're gonna talk about how to compare, how to do a goodness of fit test. What is a goodness of fit test? Well, before we were talking about binomial data, we had data that would fit, the answers would fit into two categories. Usually it was success or failure, just two categories. And with a chi-square goodness of fit, we have more than two categories. So it's a multinomial experiment. Okay, so for example, we have, do you suspect any one of the, oh, no, hang on. Oh yeah, sorry, we're here. Do you suspect any one day or set of days of the week is more or less likely to be a person's birthday than any other day or set of days of the week? What is your reasoning? Okay, so it says to answer this question, days of birth were recorded for 147. This is going to be important. 147, that's all in randomly selected people. The counts for the 7 days of the week are given. Okay, so here we're gonna call, we have the days of the week and we have uh, our observed values. We're gonna call this observed. Okay, so what are we testing? We're testing if the birthdays are basically divided evenly. And so we're gonna also we're gonna find our expected values, like if they were distributed evenly, then have 7 days of the week. So n divided by 7, my 147 divided by 7 would be 21. So my expected value would be 21 for each day. Okay. Now, of course, we live in an imperfect world, so the numbers, the observed values are not all 21. Now, the question is this, again, is this a random sampling error, or are they really not distributed? The births are not distributed evenly. And okay, yeah, we have some pretty big differences here. Like on Mondays, there are 17 birthdays, and on Tuesdays, 26. And then we have 15, and then we have 25. So, and the question is this, can this be considered consistent or not? So, what are we going to be testing? We're going to be testing if the proportions in observed data conform to the frequencies, rather, in the observed data are conformed with the frequencies and the expected values. Okay, so, and we are going to use Statcrunch for it. So basically, our null hypothesis would be that all the frequencies on each day is the same, or proportion of people born on specific day of the week is consistent. So the proportion of people who were born on Monday, same as proportion of people who were born on Tuesday, same for Wednesday, same for Thursday, same for Friday, Saturday and Sunday. Okay, now let's think about alternative. And sometimes people say that alternative is that those proportions are not the same. But think about it. In order to disprove this, do we have to prove that every single proportion is not the same? I hope your answer was no. We just have to prove that one proportion is off, and that will do it. So for the alternative, we're going to say that at least one proportion is not as stated. At least one proportion is not as stated. Okay, so what are the assumptions and requirements? So basically, we need the samples that our samples should have been selected using a simple random sample, and the expected counts are at least 5 in each category. So they say randomly selected people, so we do have random sample, and also our observed values in each category is greater than 5. So we're good with the assumptions. So let's go to Statcrunch and complete this test. All right, so here we are, and I already put my observed values, and it's good if we actually go ahead and change the name of our variable, and then we're gonna also write down the expected values. And for expected values, we have 21 cell. All right, next. And I just want to quickly mention here that if you did not expect the same frequency on each day of the week, let's say they told you that you have 50% on Monday, people born on Monday, and then 10% and then 5% the next day. You would just calculate for your expected value, you would put 50% of people of 147 people in the first cell, and then 10% of 147 in the next one, and 5 in the next one. Just calculate whatever percentages they give you, you just put them in the expected, calculate the value for the expected column. And by the way, I forgot to actually put out categories here. Let's do that. We would have Monday, Tuesday. All right, I put my categories in here. So you always have to have a column for observed values and for expected values. Observed are given to you, expected you calculate yourself. Okay, and then you go to stat and goodness of fit, chi-square test. And you're gonna select what they ask you to select, so observed values, and you go and select the column where your observed values are, and then same for expected. And we name them appropriately so we don't have to guess which one is which. Okay, and don't worry about anything else, just hit compute. And here we are. You have a p-value of 0.5623. So we're gonna write it down. And because this value is very big, it's way more than any of our significance level, whether 95 or 99, this p-value will be greater. So we will conclude that we fail to reject the null. Okay, and go from there. Let me just, okay, just scroll it down. The p-value is 0.5623 is what we found, and it's less than any significance level. I don't see any significance level given here in this problem, so I'll just assume that it's the average around 0.05 that we usually have, even if it's a 90% confidence, it's going to be, the alpha would be 0.10. Still, p-value is greater than that. So therefore, we fail to reject the null. Okay, fail to reject the null. And what was the null? The null was that the proportions are equally distributed. So, but remember, we never proved the null. We just say that there is not enough evidence to conclude that. So conclusion, there is not enough evidence to conclude that the birthdays, how to phrase it, I can't think. The birthdays happen with different frequencies depending on the day of the week, right? Okay. Birthdays happen with different frequencies. On different days. Okay. So this is how we do a goodness of fit test. Now, if you're, so here, our null hypothesis that proportions were all the same for all the days of the week. But if they were different, let's say the claim is that 50% of birthdays happen on Monday, or let's say 40, then 10 on Tuesday, and the rest are, with equal frequency, which also going to be 10, by the way. But anyway, so you would then say the proportions are as follows. Proportion of Monday is 50, proportion of Tuesday is 20, or whatever we mentioned, so forth. Just list the proportions that are mentioned, and then you calculate the corresponding observed values, and the alternative would be same. At least one of the proportion is not as stated, and that would be the difference for that example. Otherwise, it's the same.